Hey everyone, today we're diving into something absolutely mind-blowing. Google DeepMind's Gemini robotics models. Google DeepMind unveiled not one but two groundbreaking AI models for robotics, Gemini Robotics and Gemini Robotics ER. And let me tell you, this is a pivotal moment in bringing advanced artificial intelligence into the physical world. So what makes these models so special? Well, they're built on the robust foundation of Gemini 2.0, Google's flagship multimodal AI model. But now they're extending these capabilities into the realm of physical actions, basically giving AI the power to move and interact with our world. Let's start by understanding Google DeepMind's overarching mission here. They aim to build AI responsibly to benefit humanity. This isn't just about creating cool tech. It's about addressing real-world challenges and ultimately improving human lives. The central aim behind Gemini Robotics is bridging that long-standing gap between artificial intelligence's understanding of the world and its ability to interact with it physically. AI has been amazing in digital domains, but Gemini Robotics represents a significant shift, bringing that intelligence into the tangible world. A key part of this involves integrating advanced large language models into robotics. This integration enables machines to understand and interact with their environments in more human-like ways. And to push this forward, Google DeepMind is actively collaborating with Apptronik to develop the next generation of humanoid robots that could work alongside us in homes and offices. Now, let's break down the core capabilities that make Gemini Robotics so revolutionary. First up, generality. A defining characteristic is its ability to generalize its understanding to novel situations and successfully execute a wide variety of tasks without explicit prior training for each specific scenario. This is a huge departure from traditional robotics, where machines are typically programmed for narrowly defined tasks in controlled environments. As Carolina Parada, the senior director and head of robotics for Google DeepMind, stated, Gemini Robotics leverages Gemini's world understanding to generalize to novel situations and solve a wide variety of tasks out of the box, including tasks it has never seen before in training. Gemini Robotics demonstrates a remarkable aptitude for handling new objects, understanding diverse instructions, and operating effectively in unfamiliar environments. The robot can navigate around scattered items to deliver a package, which showcases this key strength. According to Google, Gemini Robotics is also adept at dealing with new objects, diverse instructions, and new environments. And get this, quantitative evidence shows, on average, Gemini Robotics more than doubles performance on a comprehensive generalization benchmark compared to other state-of-the-art vision-language-action models. That's not just an incremental improvement, it's a massive leap forward. Next up, interactivity. Built upon Gemini 2.0, Gemini Robotics exhibits an intuitive level of interactivity. Google states that because it's built on a foundation of Gemini 2.0, Gemini Robotics is intuitively interactive. It can seamlessly interpret conversational commands and adapt to dynamic conditions. In fact, it can understand and respond to commands phrased in everyday conversational language and in different languages. This multilingual capability significantly broadens its potential applications. Furthermore, Gemini Robotics continuously monitors its surroundings, detects changes to its environment or instructions, and adjusts its actions accordingly. If an object slips from the robot's grasp or is moved by a person, it can quickly replan and continue the task. But wait, there's more. Let's talk about dexterity. Gemini Robotics can tackle extremely complex, multi-step tasks that require precise manipulation, such as origami folding or packing a snack into a Ziploc bag. These seemingly simple tasks for humans require a surprising degree of dexterity, which has traditionally been a significant challenge for robots. The true innovation lies in its exceptional precision during physical interactions. Its ability to execute detailed manipulations opens up unprecedented possibilities for both domestic and industrial applications. And check this out. In a factory trial, a Gemini-powered robotic arm achieved a 15% reduction in assembly time for a car part. That's a real-world improvement that could transform manufacturing. Now, while Gemini Robotics excels at a broad range of physical interactions, its companion model, Gemini Robotics ER, embodied reasoning, takes a specialized approach by focusing on advanced spatial awareness and physical reasoning. Gemini Robotics fundamentally transforms how robots perceive and interact with their surroundings. It can identify specific parts of an object to determine the optimal way to grasp it. This level of detailed environmental understanding is crucial for tasks requiring nuanced interactions with objects. A key strength of Gemini Robotics lies in its ability to orchestrate complete task sequences from initial assessment to final execution. Testing has shown that Gemini Robotics achieves notably improved success rates in end-to-end tasks when compared to the base Gemini 2.0 model. When conventional approaches prove insufficient, the system can adapt and learn through human demonstration, significantly reducing the need for extensive reprogramming and making it more practical for real-world deployment. Gemini Robotics significantly enhances Gemini 2.0's existing abilities. Google states that improves Gemini 2.0's existing abilities like pointing and 3D detection by a large margin. The model can even instantiate entirely new capabilities on the fly. For instance, when presented with a coffee mug, the model can intuit an appropriate two-finger grasp for picking it up by the handle and a safe trajectory for approaching it. In an end-to-end setting, Gemini Robotics can perform all the steps necessary to control a robot right out of the box, including perception, state estimation, spatial understanding, planning, and even code generation. In such scenarios, the model achieves a 2-3x success rate compared to Gemini 2.0. Let's talk technical foundation now. Both models are built upon Gemini 2.0, which provides inherent strengths in multimodal reasoning. Gemini Robotics is specifically designed as a sophisticated vision-language-action VIA model for robot control. Google describes it as an advanced vision-language-action model that was built on Gemini 2.0 with the addition of physical actions as a new output modality for the purpose of directly controlling robots. Meanwhile, Gemini Robotics focuses on enhancing Gemini's understanding of the world in ways particularly relevant for robotics, with a strong emphasis on spatial reasoning. Google states that Gemini Robotics is a model with spatial understanding, enabling roboticists to run their own programs using Gemini's embodied reasoning abilities. Now, these advancements aren't happening in isolation. Google DeepMind is actively collaborating with leading robotics companies like Apptronik, Boston Dynamics, and Agility Robotics to integrate these capabilities into real-world robots. A particularly significant partnership is with Apptronik, with whom Google DeepMind is developing the next generation of humanoid robots powered by Gemini 2.0. Apptronik is currently testing Gemini on their Apollo humanoid robot, a machine designed for practical tasks such as lifting crates and fetching tools. In terms of real-world applications, the potential is enormous. In domestic settings, a home care prototype powered by Gemini Robotics has already demonstrated its potential by assisting an elderly tester in fetching a dropped remote, successfully navigating common household obstacles like rugs and coffee tables. In industrial environments, the demonstrated ability to cut assembly time for a car part by 15% showcases the potential for significant efficiency gains in manufacturing, and the performance metrics are incredibly impressive. On average, Gemini Robotics more than doubles performance on a comprehensive generalization benchmark when compared to other state-of-the-art vision-language-action models. In specific tasks, Gemini Robotics achieved a 74.5% success rate in distribution tasks, compared to 42.6% for multitask diffusion policies. The expert opinions on this technology are overwhelmingly positive. Patrick Egbunonu captured this sentiment perfectly. Imagine robots intuitively packing lunchboxes, handling delicate items, or assembling products efficiently without extensive custom programming. Looking towards the future, Google DeepMind co-founder Demis Hassabis believes that Gemini would eventually evolve into a unified model capable of powering both robotics and self-driving cars. That's a vision of convergence that could reshape multiple industries. Gemini Robotics and Gemini Robotics represent a significant leap forward in AI-driven robotics. By leveraging the power of Gemini 2.0, these models demonstrate unprecedented levels of generality, interactivity, and dexterity. Their ability to adapt to novel situations, understand natural language commands, and perform complex manipulation tasks opens up a vast array of potential applications that could transform industries and improve our daily lives.